question about packet?
I already did, but go on. What's the question?
Will we have enough room to write down everything this time?
I like to keep you guessing, so I'm going to say yes. I took 1 page of notes, so I think you will have enough space. Okay, so section 1 is all about what is a random variable and is it discrete or continuous. So this is super easy. What is a random variable? It's a variable whose value depends on the outcome of a chance experiment. So a random variable is a variable whose value depends on the outcome of a chance experiment. Okay, so again, chance experiment just means we don't know what's going to happen. So a random variable is just something that's uncertain. So if I were looking at age, you all have different ages. That's a random variable. I don't know your age until I ask you and you tell me. That's a random variable. Random variables, we're looking at numeric random variables. They can be discrete and continuous, same thing as before. So the example that they give you in the book, I think, is about if you were doing a study of grocery stores, and let's say you're standing outside the grocery store and you're asking everybody that walks out, how much time did you spend in the grocery store and how many items did you buy? The amount of time that you spend and the number of items that you buy, those are random variables. The amount of time that you spent in the store is continuous. The number of items that you buy, that's discrete. So if you remember way back in the beginning of the semester, I said discrete is generally counting, whereas continuous is normally measuring something. Woo, that was section 1.
What's a random variable? I didn't have a pencil to write it, so
That was like half of the section.
I apologize.
Okay, so section 2. Section 2 is where we're going to talk about specifically just discrete random variables. Continuous we're going to talk about in section 3. We're going to look at probability distributions using tables, histogram formulas, and then we're actually going to do some calculations. So, here's the first example that you have. This is an example of the number of heads that you could roll if you were flipping a coin 4 times. So if you're flipping a coin 4 times, you could flip no heads, 1 head, 2 heads, 3 heads, or 4 heads. You okay?
Yeah.
What's so hilarious?
How many heads do you want?
Well, when you said how many heads
Yeah.
you could roll and
How many heads you can flip?
No,
Is that better?
You just
Okay.
reminded me of like
Or
if
wording.
you were really
Thanks.
mad, you could say like
Thanks, Brooke.
We're skating on
Okay. So, label this. This is the number of heads that you can get. This is the probability. So this is called a probability distribution. So this tells you that the probability of 1 head, let's say, is 0.25. The probability of 2 heads is 0.375. So there are 3 main ways to show probability distributions: a table, a histogram, and a formula. We are mostly going to do table and histogram. We're not going to do a formula. The formula. It's important for us to decide how to come up with these numbers. Why is the probability for 2 higher than the probability for 0? Shouldn't it just all be the same? So why is the probability for 0 heads different than the probability for 2 heads?
Because there's a 50% chance of flipping a head each time. So that makes 2 times out of it more likely. And getting 4 in a row. So the chance of getting the probability of getting 4 in a row.
Yeah, I think you're right. I don't think you're being specific enough.
To get 0 heads, that means you need all 4 details. So that's
Okay. As opposed to then?
I was just gonna say, like, it's kind of like dice, like, or no, I guess it had to be a specific combination. Never mind.
Jed?
there are multiple orders in which you can flip it so that it ends up with 2 heads total?
Yeah, exactly. So if you have 0 heads, there's only one option, like Marta said. You got 4 tails. That's it. So probability of a tail is 1/2, so that's just 1/2 to the 4th power. But 1 head, that can happen a bunch of different ways. You get head, tail, 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 head, tail, 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 head, tail, 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 head. So this is still 1/2 to the 4th power, but now I have to multiply by 4 because there's 4 different combinations, or 4 different orderings. So does that make sense now how those numbers are, how we come up with those? Okay, so this formula here, so the probability of x, x being the number of heads. So this 0.5 to the x accounts for the heads. I just want to explain to you what the formula means. This 0.5 to the 4 minus x accounts for the tails. So let's say I'm looking for the probability of 2 and I use this formula. This part is called 4 choose 2, and we'll let's do 3 actually. Sorry. Let's do 3 instead of 2. So I'm looking for the probability that I get 3 heads. So this is 0.5 to the 3rd. This is 0.5 to the 1st. Again, this means I got 3 heads, and then I got 1 tail. This number out in front accounts for all the different orderings. So this is all the possible ways that I can get 1 tail. If I'm flipping a coin 4 times, how many ways can I get 1 tail? 4. Yeah, so that number in this case is just going to be 4. You don't have to know how to calculate that, but I want you to know where this comes from, what this formula means. So this is a probability distribution. I might ask you, what's the probability of getting a 3? What's the probability of getting at least 2 heads? Something like that. Okay, ready to do an example? Woo, good. Flip the page. This is the one you're looking at. Okay, so this one says 30-year averages for birth, gender, produce. The probability of a boy is 0.5126. Probability of a girl is 0.4874. In a 3-child family, what is the probability of getting a girl, and then a boy? You guys should be able to do this one. Just tell me how to do it right now. How would I find the probability of 2 girls followed by a boy? If I tell you that the genders are independent. So whatever the first child is doesn't affect the second child.
Be 0.4874 times 0.5126 to a second. Or my other way around, that squared times 0.5126.
Yeah, so 2 girls and then a boy. So that ends up being, I don't know what that is. Somebody.
.12177.
0.12177, so 0.1218. So that's the probability of getting 2 girls followed by a boy. What's the probability then of a girl, then a boy, then a girl?
Same thing.
Same thing, right? Just different order, same thing. One thing I forgot to tell you with the previous problem, when we were looking at the number of heads, intuitively you probably know this, but the table has to add to 1. The probability distribution table, because we're only flipping a coin 4 times, you have to get between 0 and 4 heads. So the table always adds to 1. Okay, so now we're saying X is the number of girls in a 3-child family. I would like you to find the probability that X equals 2 and the probability distribution as a table and a histogram. So this is really what I'm looking for the first problem. So X is the number of girls. And then here is the probability of x. It says there's only 3 kids, so you can have 0 girls, you can have 1 girl, you can have 2 girls, or you can have 3 girls. Now, to find the probability, you have to think of the different cases. If I have 0 girls, what does that look like in a 3-child family? 3 boys. That's your only option. So that's 0.5126 to the third, which is 0.1347. Okay. Take 2 minutes, fill out the rest of the table. Remember that your table has to add the 1. So at the end, if yours doesn't, that's a red flag. Check with the person next to you after you get the probability that x equals 1, just to make sure that you're on the right tracks.
You have to, so you're gonna
You have 3 different options.
a similar thing on this side. So both these two, like, you'll probably have these ones right.
Sounds maybe.
But you have to have,
Hey, Miss Bunny, you want me to my partner?
like, the different orders that it could be in.
Sure.
So it's like girl, boy,
Yeah.
girl, boy, girl, boy, girl, girl. So those are like 3 options. So the multiply this by 3. And that is.
Okay, how are we doing? Okay, if x equals 1, that means there's 1 girl. So the girl could have been the first child, the girl could have been the second child, the girl could have been the last child. So we have to account for the fact that there's 2 boys. So that's 0.5126 squared. And then we need the probability of a girl, so 0.4874. And then we have to multiply by 3 because there's 3 different orders that could happen. That ends up being 0.3842. If there are 2 girls, there's 3 possibilities again because there's only 1 boy, so the boy could be the first, second, or third child. So that ends up being 0.3653. So that's 3 times the 1 boy, so 0.5126, and then 0.4874 squared for the 2 girls. If there are 3 girls, that's the only possibility, 3 girls. So that's 0.4874 cubed, which ends up being 0.1158. and they all add to 1, which is good. How do we do? Okay, we ready to draw a histogram for it? Good, I'm excited too. Okay. So we need to get to 3 girls. So split this in half, and this is 0 girl, 1 girl, 2 girls, 3 girls. Is that about even? Yeah, almost. Okay, so down here we're going to put the number of girls. Up here we're going to put the probability. We have to get up to 0.4. So let's do 0.2 here, 0.4 here, 0.1 is about there. Of course you would do this way more accurately than I am, right? You're not just going to guess. But the first one was 0.1347, and 0.3842 somewhere here. 0.3653 is somewhere about there. 0.1158 is somewhere about there. Again, be more accurate when you are doing this, please. Okay, did we get the probability distribution part? Okay, you have a question like this in your homework for this section. Please put your answer in a table like we just did. So every year students just write out all the cases and all the probabilities. That's not what I want. I want a table that has X and then the probabilities for that X value. Got it? Okay. Second one, find the probability that there is at least 1 boy using notation in your explanation. So for number 2, we're looking at the probability that the number of boys is at least 1. Okay, but we've been talking about the number of girls, not the number of boys. So we need to convert this into talking about girls. If there's at least 1 boy, that means there's 1 boy, 2 boys, or 3 boys. If there is 1 boy, then there are 2 girls. If there are 2 boys, there's 1 girl. If there are 3 boys, there are no girls. So instead of writing it like this, I'm going to look for the probability that the number of girls is less than or equal to 2. In our notation, that's the probability that X is less than or equal to 2. So that's the probability of 0, add the probability of 1, add the probability of 2, all of which were in the table. When you add those up, you get 0.8842. So 0.8842 is the probability that there's at least 1 boy. How do we feel about this? Not too bad? Do we have any questions? Can I erase this? Okay, here's what we're going to do. There's another example, but I want to leave it